Welcome to the Crazy Hat Chemist. So another video here on acids, bases, and titration. So here we go. Bam! So today we're talking about acid-base calculation number 2. Acid-base calculation number 2. What is the hydronium ion concentration, the hydroxide ion concentration, and the pH of a 0.015 molar nitric acid solution? Okay, so here's the equation for nitric acid. So nitric acid is HNO3, that's aqueous. We're going to always add the water on the reactant side. That will help us write the products for this reaction, okay, in the conjugate pairs. So the conjugate pair to nitric acid is one less hydrogen, and that is the nitrate ion. The conjugate pair to water is the hydronium ion. Okay, you should see that the nitric acid is removing a hydrogen. The water is gaining that hydrogen to form those conjugate pairs. That's how you come up with the products of this equation here. Okay, you should see that that single arrow there between the reactants and the products is a unidirectional arrow, and it is not an equilibrium arrow whatsoever. Okay, that means that this acid is a strong acid. Okay. All right, so I have a 0.015 molar HNO3, that's nitric acid concentration. Okay, nitric acid is a strong acid, like I said before. It's one of the seven strong acids, and it dissociates or ionizes 100%. Okay, so therefore, I'm going to use a mole ratio to obtain the product concentrations. That is, the nitric acid and the nitrate ion are in a 1-to-1 mole ratio. The nitric acid and the hydronium ion are in a 1-to-1 mole ratio. So now I have the hydronium ion concentration. There it is right there. That is the hydronium ion concentration, because I know that nitric acid is a strong acid. It dissociates 100%. Okay, and I'm using the mole ratio to obtain that value of the hydronium ion concentration at 0.01 molar. The pH is equal to the negative log of the hydronium ion concentration. So I've plugged in that hydronium ion concentration value right in there. Okay, and I'm going to take the negative log of that value, and that is going to give me a pH of 1.82. Does this number make sense? Well, nitric acid is a strong acid. Since it's a strong acid, it will have a pH that is less than 7. So that pH value does make sense. And since it's a strong acid, it must be a pH value that is very, very low. And that is 1.82. That pH has 2 decimal places. That's also important. Okay, all right, now I need to get the hydroxide ion concentration. So there are a variety of different ways of doing this by all those equations that you have memorized, but this is what I'm going to use this time. I'm going to use the Kw. The Kw is the ion product constant of water, and that is the hydronium ion times the hydroxide ion concentration. That's equal to 1.0 times 10 to the negative 14. That is the constant for that. That's at 25 degrees Celsius. There's an assumption for all these problems that they will be at 25 degrees Celsius. So I'm going to plug into this equation right here the hydronium ion concentration. I've done that right there. Now I am going to divide both sides by the hydronium ion concentration to obtain the hydroxide ion concentration, and that's what I get right here. So the hydroxide ion concentration is 6.7 times 10 to the negative 13 molarity, which is moles per liter. Okay, so now I have solved for the hydronium ion concentration, the pH, and the hydroxide ion concentration of a strong acid that dissociates 100%. That is part of the key here in solving this problem. Okay, I'm hoping you enjoyed that problem here. I am the Crazy Hat Chemist, and I am the king of chemistry problems, baby. Yeah, give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'm going to see you next time for more cool chemistry problems. Bye for now.